Hello, everyone. My name is Judith Hurwitz. I am the Chief Evangelist here at Geminos Software. It is wonderful to have you joining us for this exciting webinar hosted by our CEO, Stuart Frost. And Stuart is going to be giving you an in-depth look at how causal AI and causal knowledge graphs can really transform decision making for your organization. So, with no further ado, I would like to introduce Stuart. Take it away.
Thanks, Judith, and good day, everyone. As Judith indicated, we'll be talking about causal knowledge graphs and making decisions at enterprise scale, which is really, I think, the first time that we've been able to deliver this. So I think it'll be an interesting conversation. Just share my screen again. So let's talk a little bit about what we'll cover today. First of all, what we're seeing in the marketplace is there are two clear paths to truly AI and data-driven decision making. As you'll see, we think one path is wrong and one path is right. And you might guess that the right path involves causality, causal AI. But there are barriers to adoption of that. And what we're doing is working extremely hard to overcome those barriers and really lower them to the point where you in industry and business can actually leverage this breakthrough technology. We'll particularly be focused on LLMs and agents and how causal AI, all of those things complement each other and can be used together to deliver this breakthrough. And a key part of it is that we're creating these causal knowledge graphs to underpin everything that you're doing. So they become really the hub of all of your AI initiatives going forwards. And we'll talk quite a bit about how they're built and maintained, because in the past, knowledge graphs have been quite difficult and they've taken a long time, they're never finished, all the usual challenges with that kind of thing. What we're finding is that all these technologies now are coming together to make that a lot easier, a lot quicker. We can do them piece by piece, and we can curate them over time and really create something that is incredibly useful at enterprise scale, not just in terms of your AI initiatives, but also in terms of truly sharing knowledge across the organization. Once we've gone through all that, we'll have a Q&A session. Steve will come back in and ask a few questions. So please feel free to put those in the chat as we go. So first of all, if we're really looking to drive our decisions using AI, what are the alternatives? And a lot of hype about LLMs and agents and RAG and all kinds of new technologies coming through. In our humble opinion, they're useful, but they're not going to do the job. The LLMs are too prone to hallucinations. Agents are still fundamentally based on LLMs. So guess what? They have problems too. And general RAG doesn't really solve that problem. So what we're doing is taking those tools, using them to help us build a causal AI platform with these causal knowledge graphs that is a much better path. And while it's complex, it is right in our opinion. And we're starting to deliver real value at scale with these technologies. So I feel very excited about this as an entrepreneur because I feel like finally I'm able to deliver on that big vision that I've had now for really more than a decade of driving these kinds of very complex decisions at the end of the day, making it easier to actually deploy these technologies so that you can make truly data-driven decisions for the first time. It's been a promise for a long time. It's been talked about for a long time. The industry hasn't delivered on it until now. And I think Geminos is right at the forefront of making all that happen. Let's just take a step back here and talk about what causality adds to the AI picture. There's a lot of conversation around, correlations and up causation, etc. All that is true. And obviously, traditional AI is based on correlations. It looks for patterns in the data, tries to make observations and predictions from that. As I think we all know, it's useful. It's not doing the whole job. And what Causal AI really brings to the table, interventions and counterfactuals, and a really deep understanding of what whatever it is, industrial process, business process needs to do. What is the key outcome that I'm trying to manipulate? What if I change something, etc. And the math and scientific underpinning of Causal AI delivers on that. So it's really quite a radical shift from traditional AI. And this is really important when it comes to making business decisions, because at the end of the day, what our customers want to do, what we all want to do, is that list of things on the left. We want to understand, why is something happening? Why is this key outcome drifting in some way? What can I do to mitigate it? What would happen if I changed something? What if I had done something differently? Counterfactual analysis. So all of these things, at the end of the day, it's okay, something key in my business is changing. Why is that happening? What do I do about it? How do I change that? How do I fix it? And that is at the core of every decision we make. And frankly, it's simply not possible to do that level of analysis with traditional AI. And LLMs are just another form of traditional AI at the end of the day, on a very large scale. But also fundamentally language engines, and they don't understand time series data, etc. With Causal AI, we can address all of those problems. So that's fundamentally what we've been focused on the last few years, had great success with that. Now what it's time to do is really make it enterprise scale, make it easier to adopt. Because there are barriers to success in this, and people new to Causal AI see all these problems. There's skills gap, yes, lots of people are coming out of university with some knowledge of causal inference. But if you start looking at the research papers, it's all very academic, very complex. The math is challenging. All these other problems as well with, knowledge graphs are never finished. We need a knowledge graph. So lots of challenges. So what we've really started to tackle is how do we break down these barriers, make it easier to use? And what we're finding is this combination of the Causal AI tools, Causal Knowledge Graph, leveraging these new AI technologies like agents and LLMs, makes it all a lot easier. So we're really creating, I think for the first time, this platform that is truly enterprise scale, that can help you perform these tasks and get to success much faster. So you do get this accelerated value. We're seeing customers starting to set up centers of excellence around these concepts. We're starting to deliver significant value. We're seeing projects that deliver results in the first year in the tens of millions in terms of additional revenue or additional profit, reduced costs, etc. So this is having a real impact. And really, as I said, for me, it's the first time we can do this truly at scale without all the classic problems of building these kind of systems. One of the things that we've talked about over the last few months is this parallel with Daniel Kahneman's thinking fast and slow. We talk about decisions fast and slow. So LLMs and agents can be quite good for knowledge capture and dissemination, obviously need to be used carefully. So somewhat similar to Daniel Kahneman's fast thinking or system one thinking, where perhaps the result doesn't have to be absolutely correct in all cases. We can accept a bit of fuzziness, but what we want to do is make a good decision quickly, spread that information quickly, but still suffering from some of these problems, lack of precision, etc. Causal AI, it does require modeling, it requires, to more precision, etc. But we do get lots of benefits from it, because when we want to make a specific data-driven decision, LLMs and the agents simply aren't going to deliver on that. So we need the precision of causal AI. We need to take our time about that. Not necessarily at decision time, that can be very quick, but in terms of building the model, understanding the business, talking to subject matter experts, etc., it's very important that we take our time about that and get it right. So it's really strong for these key decisions. And what we're finding is that if we underpin all of this with the causal knowledge graph, we can actually introduce quite an interesting kind of positive feedback loop here. First of all, we can use the LLMs and agents, as you'll see in a few slides' time, to help us build this causal knowledge graph much more quickly than was ever possible before, and then curate it over time. But also then, as we go deeper in and use causal AI to make specific decisions, we can bring that deeper level of knowledge back into the causal knowledge graph, which then allows us to get better results from the LLMs and the agents, which then feeds back into being able to build causal AI projects more quickly. So we start to get, as I say, this positive feedback loop. And it's really playing out in customer sites right now, where we can, for the very first time, build these knowledge graphs, and then it can be used as the foundation for really all of your AI efforts. And that's a significant shift. Let's talk about that a little bit further. So as I said, we're really seeing the CKG as the hub of this and building it for enterprise scale, etc. What we need to do is capture all the knowledge sources. We need to capture structured data, unstructured data, we need to understand timelines. So if we've got a set of time series data, where do inspection reports fit on that? We need to be able to capture SME knowledge, so subject matter expert knowledge. Ultimately, we need to add in business rules, and that's something that we're working on for a future release. So it's not just causal information in the knowledge graph, it's also the business rules. Let me just dwell on that idea of adding causal knowledge. A traditional knowledge graph, to my mind, captures the kind of static structure of your business. It's, I've got this many sites, they have this equipment there, they have these people, this piece of equipment contains these other components, etc. What's been missing, in my view, is the dynamics of the system. And that's what causality really brings to bear. If this variable changes, what happens to this variable? If this set of variables change, what happens? And what do I do about it? So really starting to introduce that layer of dynamics. What is really going on in my business? Now, what we're starting to do is add in this agentic layer, so it's much easier to build these systems. And what we're doing is really taking it step by step. So there's human in the loop quite a bit here. So as you'll see in a few slides' time, we use the agents to actually interview SMEs to say, hey, we spotted a potential problem in the knowledge graph here, help me resolve it, go step by step through it. And we're finding that's a way to really reduce the impact of hallucinations in the LLMs, etc. But also what we're seeing is that as we build that knowledge graph and as it gets more and more information about your specific situation, and that's used in a really direct way because it becomes an actual database query as opposed to a somewhat fuzzy LLM type thing, we get much better quality results out of the agents too, especially when we do the step-by-step approach. So it really does build on itself quite quickly, and we can do it use case by use case. We don't need to do some grand enterprise-wide knowledge graph that's never finished. We can take it step by step. The other thing that we're going to start to do is offer fundamental underpinning knowledge graphs for various industries. We're starting with oil and gas, particularly with midstream. I've got some projects going around refining right now. So that's something we're starting to build out and we'll offer it as part of the platform. So that will initially focus on markets where we're active right now, like oil and gas, chemical production, various forms of manufacturing, inventory management, that kind of thing. So you'll start to see these ready-built knowledge graphs come to market over time. And as I mentioned then on the knowledge consumption side, this CKG really becomes the hub of your AI initiatives because it can be used through a standard LLM interface, and users don't really know that that's happening, the LLM kind of effectively goes to the knowledge graph first, gets that, puts that in the context window, and then the answer is based on the information in the knowledge graph, obviously, and also the broader information in the LLM. That's a great way to spread knowledge around the organization. But we also might want to do very specific agentic AI, for example. Again, that can be based on the CKG and leverage all the knowledge that you're building there. Even your regular machine learning, deep learning projects can do that because it's all an open architecture. You can query the knowledge graph directly if you wish. And that's kind of what we do in our Causal AI projects as well. In some cases, we use the LLM-based interface. Some cases we use agentic AI within the Causal AI platform. And in other cases, we just go direct to the knowledge graph, especially when we're doing the feedback of, I've got a new causal model. Now I need to insert that into the knowledge graph and add value to it. So that's the kind of full picture of where the platform is being developed. As I say, making, I think, intelligent use of agents throughout. And we're using all the standard kind of agent frameworks, so it's all compatible with what you'd expect, not inventing the wheel here all over again. Let's talk a little bit deeper about the knowledge graph and what it looks like. So what I've got here is a general causal knowledge graph. You'll see actually there are some causal relationships here that are starting to come in. And you could view this as the kind of base level that will ship with the knowledge graph system. So we've already done some extraction and curation from industry standard documents and information on the internet, etc. This obviously goes way beyond what a normal LLM would understand because these are very specific knowledge relationships that are kind of industry-wide. The next step is to ingest those documents, and we're at the point where we can ingest tables and text, and we're adding graphics to that as well. And so it is multimodal. We're using agents to help walk through that process and do it at scale. So what we can see now is that we can add more knowledge here. So this is starting to be specific to your business. And we are building in the capability to have kind of private sections and so on, so layers of knowledge to protect your IP, etc. So that's being built into the system. And we see here we've added quite a bit about kicks and what happens with that, what the causes are of it, etc. So starting to get more specific. But the problem is, as we add more information, we sometimes get conflicts. This is pretty common when you're building the knowledge graph. So here what I have is some initial causal information about dew point corrosion. So when the temperature drops below a certain level, the gases in the pipeline can actually drop down and become liquid. That causes more corrosion, so it causes degradation in the pipeline. Very common situation in refining and various aspects of oil and gas production. Now we're pulling in a maintenance and system upgrade report. So this is, again, really specific to your situation. This is one of a customer's, it's not a specific customer's document, don't get me wrong, but it's an example of a customer's document. And here what we can see is they've actually installed, oh, I'm sorry, fix ahead there. They've actually installed an automated trip system, which prevents dew point corrosion. Once the temperature gets below a certain level, it triggers the trip, the pipeline shut down, so we don't get that dew point corrosion. This is obviously just an example of the kind of thing that might be happening. Okay, now we've got kind of two versions of the causal paths here, and we need to resolve that. So first of all, what will happen is that the agent will detect that there is now a potential conflict. So the agent will then go to the database of subject matter experts that it can ask about these questions, figure out the most appropriate person or people to ask about this, explain the situation. So we've just brought in this new report. There's an automated trip system to prevent dew point corrosion. It conflicts with the previous knowledge. So what should we do about it? So the person now is interacting with the system, saying that it's been installed in some pipelines, but not all of them. So we need to give both sets of knowledge. Okay, so now the AI agent will make an attempt at actually addressing that problem and come up with a system that combines the two. So it's basically now created two different kinds of entities. So it's split the pipeline effectively into ones without the trip and ones with the trip. It's one way of addressing the problem. Um, and here now we can see that in some cases we don't get dew point corrosion. Now, there might be other causes of corrosion as well, which would be in parallel with this. Those would not be affected because we can have inheritance effectively in this knowledge graph. But here, the agent is just interacting with the subject matter expert to make sure it's made this change correctly. So yeah, that can be confirmed by the subject matter expert, and it will actually be added to the system by the agent. And then we can actually link to the Causal Knowledge Graph so the SME can check it. And then, yep, all looks good. So now we're going to have that start point of curating the knowledge graph. And this can be happening in parallel with multiple people. We can have potentially access to lots of different subject matter experts. We can even open up potentially to outsiders, right? Because this is all done through agentic AI through email and other interfaces. So very flexible, and we can basically curate the knowledge graph over time. And we can start with specific use cases. So we've got the industry-wide foundation of the knowledge graph. Great, it's a good start point. Now we want to address particular pipeline corrosion problems. Let's start there. And then once we started to bring the knowledge in, we'll actually start to do causal AI projects too, and do causal modeling of that, which will obviously over time increase our confidence in that, increase the quality of the information, and make the whole knowledge graph a lot richer. So that's where that positive feedback loop comes in. And we're finding this is a really effective way of building these knowledge graphs, the causal knowledge graphs. Really, for the first time, we've been able to do this at scale and do it in multiple industries. Just to summarize, we've got these two paths to AI-driven decision making. Obviously, we think the path we're taking is the good one, and causality is a key part of that. There's no question. Once you've started using causal AI, you kind of don't go back. Once that light bulb goes on, and you see it's just a better way of delivering on AI projects, you don't turn back. And we've seen that over and over again. But it can be a bit scary to adopt in the first place. So we've really focused on overcoming those barriers and adding all these technologies in, using LLMs, agents, etc. That I think are great complements to this and allow us really to do enterprise scale for the first time and build that CKG ecosystem. So you can use it as the hub of all your AI initiatives and use it for knowledge sharing, etc. And obviously, we talked quite a bit about how those are built and maintained. So if you want to see more detail, please use the book a demo QR code there and get in touch with us. We'd love to show you this in more detail. Thank you. Well, at this point, I will hand it over to Steve again so you can ask any questions that have come up.
Oh, thank you, Stuart. That was great. Yeah, we've got quite a few questions that have come in the Q&A and also through direct message. So first one that came in really was a request for customer examples where Geminos had a clear ROI for a customer. So examples of industries and types of project.
Yeah, sure. So we worked on a project last year for a major manufacturer, for example, where we were helping them to really understand the broader implications, the kind of macro level challenges around their inventory management and their ordering and their whole supply chain. Systems like SAP are pretty good on doing short-term things, what I would term the kind of micro parameter setting. but they don't understand that bigger picture. And this becomes a real challenge because what often happens, especially with seasonal production, you end up with basically overloaded suppliers, lots of what might be premium freight happening there, and it ends up being very expensive. So we actually showed savings of tens of millions of dollars for that customer. It's obviously a great result. Also doing quite a bit in terms of helping people in, especially in the oil and gas business and refining, etc., to really improve downtime, especially unplanned downtime. And we're seeing benefits there of 10 to 20%, which can result in literally millions of dollars per day sometimes of increased production or reduced costs. So we are starting to see some real great ROI stories here, which is very encouraging to see.
Brilliant. Paul asked, how is the causal knowledge graph adapted for different industries? I think we covered some of this in your presentation. And how often is it updated?
Yeah, so as I mentioned a couple of times, there is this, we're building these foundation models for different industries. So starting with oil and gas, because that's where we have a few different customers that are starting to deploy this. We'll obviously do manufacturing, might do agri-tech, and really wherever the customer base takes us, we'll continue to add different things there. And then as you build it and make it more specific to your circumstances with, new inspection reports, whatever, that's a continuing process. There's typically, when we first start out, as we said, we do it use case by use case often. So we'll take in documents specific to a particular piece of equipment that's problematic or a particular outcome that a customer wants to drive, like improved downtime, for example. That takes a few weeks to do the initial ingestion and some basic curation on that, resolving any initial problems. And then, it's an ongoing thing. Obviously, there are always new inspection reports, service logs, whatever, new documents come through. We might have to resolve issues between different versions of a given document or all those kind of things. So it's ongoing, but a lot of the curation now is happening as we go through the agentic AI technology that we're building in. So yeah, the whole idea of this is that we can start relatively small scale. We can even start with different groups doing different use cases. So we do things in parallel, all contributing to the same underpinning knowledge graph. So the barrier, in our view, is much lower than it ever was. It's not zero, of course. These things are powerful and do take a bit of effort, but the ultimate benefit from this is enormous. We are seeing those kind of ROIs in the tens of millions of dollars, so it's definitely worth putting the effort in.
Great. The next one here is, I'm just trying to understand the question from Kearthana. What is the input feeded for agent? Is the question. I'm guessing what inputs do agents take?
Yeah. So it depends on the circumstances, right? In what I was describing before, agents are being used to ingest the documents and to help with that process, right? And bring that, understand what a table means, for example, understand what a drawing might mean in a document in terms of knowledge artifacts, right? So entities, relationships, causal relationships, ultimately business rules, etc. So in that case, the inputs to the agents are documents, and we're using IBM's Dockley to basically parse the document and break it down into chunks and so on. So we're using agents kind of internally to help us do that. And then at the next level, when we're doing curation, the agent is looking at the actual knowledge graph, looking for potential conflicts like the one I described. So in that case, it's going to write some queries against the knowledge graph through an LLM, etc. Come up with some potential conflicts, and then go out to typically email or whatever, or Slack or whatever you want to use really, to ask subject matter experts to help it resolve those problems. Some areas, though, then that we're working on are more in, for example, like ETL, etc. So, okay, I've got a piece of a causal model that is in the knowledge graph. Now, what I want to do is actually instantiate that against real data and start to build a causal model to make a specific decision. So now use the agents, use different agents, to go look for appropriate data, right? And help me set up the ETL process to get that from my data lake. And at a later stage, we haven't built this out yet, but ultimately, when we're making decisions, the causal model is telling me there's a problem, what to do about it. Help me understand at that point of being the operator, what the trade-offs are, what is really happening there. Express it to me in general, in natural language. So the agents at each stage are taking different inputs and creating different outputs and very specific jobs, though, right? We're not claiming one agent is doing all this at all. These are very targeted, ideally single-step agents as they interact with humans and get it checked. Because fundamentally, if an agent is based on an LLM and you're asking it to do many steps, it only takes one of those to hallucinate, and it's going to be off in the weeds. It's one of the fundamental problems with agents. So we're really taking steps and being careful to avoid that kind of scenario.
Great. So another question, this is from Jagdish. The decision recommendations would presumably be probabilistic. So how are those interpreted for actual decisions stroke actions? And what kind of training is needed there?
Well, at the end of the day, I suppose every decision is probabilistic, right? And every use of AI is probabilistic to some degree. With causal AI, at least, you do have that benefit of the causal math underpinning it, where you can, first of all, in historic data, really understand what is going on and more about the probabilistic nature of actually what's happening. Anytime you're doing root cause analysis, the reality is it is probabilistic, right? It's giving you the most likely outcome. What you can then do, though, is test your interventions. So right at the point of an operator, if necessary, you can say, okay, try moving this by 10%, and not actually on the working system or on the industrial process, but in the math, right? You can say, what will happen if I change this? What's the most likely outcome? So, providing training to understand what's going on there and ultimately providing that agentic help and the LLM-based help to understand that is going to be very powerful. At the end of the day, I guess our philosophy on this is at the moment, most of these decisions are taken using gut feel and just what people remember in their experience, etc. What we're offering here is, for the first time, a truly data-driven scientific approach that will give you significantly better results and more consistent results across a team of people. And also, that knowledge doesn't walk out the door and maybe never come back at some point, right? If they retire or whatever. So, yeah, it is probabilistic at the end of the day, but it's a lot more accurate in terms of probabilistic nature of it, or statistically, than a human being, right? That tends to make most of their decisions using fast thinking rather than slow thinking in reality. That's problematic, let's face it.
Great. So Kevin asked, how long does it typically take to go from an initial setup to seeing value with the Causeway platform?
We're getting quicker and quicker at this all the time. So, for example, if we do a proof of value project, depending on the complexity, of course, but it can be anything from a few weeks to a few months. It's not by any means years. The first use case typically takes a few months, which is generally better than traditional AI. And I think that's partly because you do have to actually understand the system and build the algorithms appropriately. And that tends to be just a faster path at the end of the day. So one of the reasons why once the kind of light bulb goes on, you don't go back. It's just a better way of understanding the problem. All too often with data science, traditional data science, we spend an awful long time cleaning up all the data that we might need because we don't really know what we will actually need in the end of the day. Causal modeling helps overcome that. We can focus in on the data points that are truly causal in the system that are actually going to have an impact. If something's missing, we can figure out up front how to deal with that, as opposed to maybe finding out once we've deployed the system with traditional AI. If there's bias in the system, we deal with that at the point of modeling and so on. So the massive improvements in transparency, reduced bias, understanding unobserved, especially if they're confounding variables, just helps us move the whole project a lot faster because we're tackling those key issues right up front. And then everything flows faster from that. So yeah, it's typically months, certainly not years or anything like that.
I guess just to add to that as well, in some of the projects that we've engaged with, you know, the value from that project in terms of insights that we've gained, it's been pretty quick. You know, we might not have deployed a solution, but, you know, with that, you know, we can get value from the project and those insights within weeks sometimes, you know, yeah.
Absolutely right, because
Mm.
you do have improved transparency because business users can look at these causal models and tell you whether they make sense or not in their terms, right? Whereas what are you going to do? Show them some algorithm? You know, they're not going to really understand that. So the dramatic improvement in transparency right from day one will often drive those kind of insights very, very quickly.
Great. Carla asks, what is the reasoning behind using the causal knowledge graph rather than classic directed acyclic graphs, DAGs? And have you found that the knowledge graphs return better results than DAGs?
Oh, okay. So just to explain that, we do use DAGs for the causal modeling. It's traditional kind of Perlian DAG-based causal modeling, if you like. In the knowledge graph, then those are effectively DAGs, the causal aspects of it, but they're combined then with information about the equipment, where it resides, what it's connected to, what it contains, etc. So there's a kind of two levels to this, if you like. The causal knowledge graph is a graph structure, and in some portions of that are DAGs. But that is also much broader, and it's also not specific to a given data set. So once we start doing a causal model and building a DAG for that, we're then talking about a given outcome on a given time frame with a given set of historic data for a given set of things. So if you like, what we're doing is taking the information on the knowledge graph and we're instantiating that specifically for a circumstance that we want to model for a specific decision. Okay, so that's the difference. In effect, the knowledge graph, the causal knowledge graph, is not decision specific, right? Because it sounds like, as you'll know, if you're familiar with DAGs, basically a DAG has to have a very specific outcome, and it's for a given period of time that you're analyzing it and building causal strengths and that kind of stuff. So what we're doing then is feeding the better understanding of the general causal knowledge back into that knowledge graph. But the causal modeling is still used for that specific decision. We are looking at ways of blending those two more and more over time, but right now that's why, hence the fast and slow thinking, right? There are two parts of the brain that we're building here. And it's important to keep those separate and think about those in that distinct way.
Great. So Nathan asks, what is the typical starting point? Do you start with the CKG or do you start with the causal model? Do you start with data science and then make your way into causal?
Yeah, that's a great question.
Where do we begin?
So certainly on the latter part, right, you do need data scientists to do some of the nitty-gritty work on the causal model. But I wouldn't say start with data science, because start doing it with Causal AI. It's just better. And you'll find then that all the traditional data science skills come to bear as you go forwards there. In terms of, do you start with a knowledge graph or do you start with Causal AI? It really depends on the circumstances. Some people just want to use the Causal AI tools. That's fine. They can be used in the absence of a Causal knowledge graph. Obviously, we recommend the use of both together, but they are separate but very complementary systems that can leverage each other. But yeah, in general, I would say people start, okay, help me understand why Causal AI is better, drive better results on a given problem that I have. Oh, wow, now we're seeing the results. We want to spread this across multiple projects. How do we do that? Now it makes sense to start investing in the Causal Knowledge Graph. So you can share all that information, you can build it up. You can also ultimately take it enterprise-wide, right? So, and it has its own power as well then as you start to do that. But I would say the general path is start with Causal AI and then add the knowledge graph over time.
Great. And we've got two questions very similar from two different attendees. So Rodney and Robert. Rodney asks, at this point, what industries, verticals are you finding are most receptive to Causal AI adoption exploration? Robert phrased it slightly differently. What industry verticals do you see Geminos becoming important to? You mentioned large-scale oil and gas and manufacturing. How about retail or FMCG, consumer goods, trading and shipping?
Yeah. Right now, I would say we tended to have more success in industrial sectors and oil and gas, energy more broadly, actually. Done a couple of things in nuclear energy and green energy and so on as well. So I would say energy broadly, manufacturing, but some of that is consumer-oriented goods, not necessarily, heavy equipment for industrial use. So yeah, we're seeing some of the same challenges across those different sectors in broad terms. We're also getting quite a bit of interest in marketing. Causal AI has been quite strong in that area for a while now. So we're starting to get some customers in that area too. So we're seeing it broaden. We've tended to stay away from healthcare or financial services, not for any particular reason. We just have to be focused somewhere, but it's not to say that technology can't be used in those areas. Yeah, right now, I would say mostly energy, manufacturing, of both consumer goods and heavy equipment.
Great. We have another question from Robert, actually. He's asking, is it difficult for business managers to engage with the platform and get value from it? Do you need qualified data analysts to use the platform, and what sort of level of training is required? So data analysts, data scientists.
Yeah, that's a good question. Let me answer the last part of that first. So I would say that data scientists, certainly if they've read anything on causal inference or anything, will find this very easy to adopt. There are some subtleties around DAGs and so on, but we've lowered a lot of those barriers, and it's getting easier and easier all the time. From a business user's point of view, drawing a basic DAG, they very quickly get the idea. Once you go beyond thinking it's a flowchart, which it definitely isn't, but the basic level of if this variable changes, the next one in the chain is going to change. That's not a complex concept at all, and it kind of fits with the way humans think about problems anyway, once you step back from it. So I think that gets fairly natural. Now, obviously, once it starts to get to the point of ingesting data and doing causal analysis on that data, that's more in the realm of a data scientist. So we typically talk about hybrid teams with subject matter experts, data wranglers, data scientists, etc., working together. As we start to do more and more on the agent front, some of those areas, like data wrangling, for example, will get less and less important, perhaps. Early days, though, in that transition as yet. But where it's clearly from a data lake, the data's well documented, you can automate some of those steps, but it's rare that the data's that clean, right? So, but agents are coming in from other vendors that we'll leverage in an open source community that help with those problems too. So over time, that will get easier and easier. But what it's fundamentally about is subject matter expert, a business manager that needs to solve a problem, and the data scientist interacting on the platform. We don't believe that barrier to be very high, quite honestly, at that level.
Right. And just in regard to the scope of the causal knowledge graph, we had a question from Kevin, and I'll just recall Carla's question as well. But in regard to Carla's question, that seems like a big or rather never-ending task. And the question that Carla asked was around the, what's the reasoning behind the causal knowledge graphs rather than just using directed acyclic graphs. So it's, the question is really, could that be an extremely large or never-ending task?
Well, what I would say is that gathering knowledge to the point where it can be shared and it's in a form that is valid for the organization is a never-ending task, right? Because the knowledge is constantly changing. So by definition, to a certain extent, it's a never-ending task. The question is whether you can get quickly enough to the point where it delivers significant value, right? The problem with traditional knowledge graphs is they haven't got there, right? You've had to bring in these massive ontologies, you had to interview a lot of people, had to deal with all the vagaries of NLP and everything, and then how do you expose it to the world? It's a database, very challenging. In this new world of LLMs and agents, first of all, we can actually ingest the knowledge, not just more quickly, but more accurately, right? And that accelerates because the LLMs then leverage the knowledge graph that they're kind of helping to build, and the agents do too. So they just get better and better at that over time as well. So the end result is that initial hurdle is much lower. And then the ongoing curation of it all, we're automating a lot of that through the use of agents and these kind of curation loops, etc. So the end result is that really for the first time, we can build these at enterprise scale in a practical way. It's also the way we recommend doing it is use case by use case, right? So you don't try to do a massive enterprise-wide initiative that no one's ever happy with, right? Build it by use case, prove the value of it, start to spread the underlying layers of knowledge as you go through each use case, and like I said, prove the value and get results quickly. And overall, now it's partly why I'm so excited about this, right? Because I've struggled with those issues in my career as a startup entrepreneur. I've done multiple knowledge-based systems and AI-based initiatives and so on. Struggle with those issues. I'm really excited about this because I see it as a massive breakthrough, and the confluence of all these things kind of coming together really make it possible to solve these challenges for the first time. So that's incredible.
Right. I think that's pretty much everything. We have a few other questions which we'll respond to offline. We'll make sure all of the questions and answers are available to all attendees as well. But yeah, unless there are any other last minute questions coming in through Q&A, I think we're pretty much there. So yeah, thank you, Stuart.
Yeah, no, thanks, Steve.
Very insightful.
Thanks for everyone for attending, and look forward to getting to know you a little better over the coming months and years as you interact with Geminos. Thanks very much. Goodbye.
Thank you, everybody.